Time to start looking at the last section of the transformations. It's called inverses. And what does an inverse mean? Well, actually, an inverse function just means that the x-coordinate becomes the y-coordinate, and the y-coordinate becomes the x-coordinate. Huh? That's right. An inverse relation means that for every ordered pair xy in a relation, there is an inverse relation yx. Oh, well, that's kind of cool. Okay. Well, look at what the textbook wrote for us here. It says an inverse of a function. If f is a function with the domain A and range B, the inverse of a function exists, and it's noted by, look at this little notation. You note an inverse by going by -1, but I'll get to that in a minute. But notice how the domain becomes B, because this was domain A, but now becomes B, and the range, which was B, now becomes A. So basically means that Y and X are just interchanged. Well, that's kind of cool. Okay, so with that in mind, let's keep on going. Let's look at the mapping and replacement notation. This is the easiest one. All you're going to do is take every xy, you're just going to make it yx. Just exchange the x and y values. That's all you got to do. Same with replacement notation. Y equals f of x was our original. Guess what? X now is f of y. Just again exchange the x and y values. Is it really that simple? Yes, it is. Okay, let's keep on going then. There's some important information that goes along with this. Oh, important information about inverses. Hey, how do you like that? Okay, graphing. When the graph of a relationship is given, the inverse can actually be graphed as a reflection in the line y equals to x. Do you remember when we were doing this? We're always reflecting over this axis. There's our vertical reflection over an x, or there's our axis here, and we're reflecting this way, and we go a horizontal reflection over y. Well, what I'm going to show you a little later on, not this podcast, but a little later on, there's a beautiful line that goes right through here called y equals to x. And what happens is that this now becomes your mirror line. So if you have a graph over here that looks like this, guess what? You're going to mirror it to over here. And it's going to look like that. There's your original. That's your inverse. That's how it's going to work. Now, cool thing is you might actually get some more invariant points, because remember, whenever you're dealing with a mirror, you're dealing with invariant points. And the invariant points, remember, on this, the invariant points are the ones that are in contact with the x-axis. The invariant points in this one, the ones that are in contact with the y-axis. And guess what? The invariant points on an inverse are the ones that are in contact with this wonderful axis we call y equals x. That's it. That's how simple it is. Really, really, really simple. And then we talked about this already about the domain and range here, which is very, very cool, because the domain and range is basically what happens with the definition that the textbook gave us. It says the domain and range are also flipped. So what was the domain is now the range. What was the range is now the domain. Aha. But let's keep on going with important information. Do you remember this guy? Vertical line test? Yes. VLT. Oh my gotcha. Let's go back to this little diagram I did earlier. Remember how I had that nice little diagram that said, okay, here's my y equals x line coming right up through there, looks kind of like that, right? And then I said, okay, here's the graph over here like this. And then I went, okay, map it by going and doing a reflection. And so it's over here like this and like this. Okay, check this out. This, if you do a vertical line test on the original guy, look at this. Vertical line test means it only touches this thing in one spot, no matter how many vertical lines that we put through. Okay, but watch what happens if I do a vertical line test on the inverse. Guess what? It's no longer a function. It cuts through 2 points. So your inverse may not necessarily be a function. But let me show you something else. We actually have kind of a little thing that goes along with the vertical line test called the horizontal line test. Huh? Never heard of that one before, I bet. Well, of course you haven't, because this is all brand new to you. Now, here we go. Let me show you the inverse again. Right through there, like that. Okay, now, the cool thing is, what happens here is this. Here's our function here. Okay, here's our inverse here, right? Come on, there it is. Okay, now, if I do a horizontal line test, this will tell me right away whether or not the inverse is going to be a function. Because if I draw a horizontal line test right through here, it cuts through 2, which mimics, guess what? The vertical line test here. And guess what? That tells me if it cuts 2 places horizontally, that means, guess what? The inverse will not be a function. That's what this whole jargon here is all about. Okay? Now, there's just a little bit more information that you need to know, and it's right here. It's something called inverse notation. Inverse notation is very, very important because what happens when you can actually write this in several different forms. One of the forms that you might see is this, where the x and y's are interchanged. Okay, but the more formal way of writing it is actually with this little -1 here. Okay, this y, f of -1 means inverse. That's how it works. And this means that this is going to be reflected in the line y equals x. You'll see this all coming up and a whole bunch of examples coming up. Now, a lot of people think about this in terms of the Math 10 idea. In Math 10, what happens is that we'd say, oh, if you got a negative, that just means to flip it and take the reciprocal. That does not happen in functions. So that's why I put this big note here in your notes. It says that -1 does not represent an exponent. So in other words, you cannot just flip the function. You actually have to interchange the x and y. So in order to do this properly, you got to make sure that you're going to interchange the x and y's of the original function. And then, of course, let's just solve this as a y equals 2. All right, so in the next coming questions, the next podcast, I'm going to do example 1 here, and we'll see what we can do. So stop this podcast now, go back to the beginning, and just watch all this stuff again so that you can get a really good idea of what all the important information, all the theory is, so that when we go into this practical application question, you'll get it right away.